Okay, so today we're going to talk about 14.2, which is adding and subtracting polynomials. Now, basically all of this is going to do is go over a lot of vocab to make sure that we understand why we can do what we're allowed to do when it comes to adding and subtracting of these polynomials. Okay, so let's get started. What is our essential question? How do you add and subtract polynomials? Well, of course, I always give you the answer just so as you're going through, you understand why that is the answer. Okay? So polynomials are added by combining like terms. That is a great term that we've been going over lately. Combining like terms of the polynomials. One polynomial is subtracted from another by adding the opposite of the polynomial being subtracted. So we'll go over this a little bit further. I'll break it down into your language. Vocab. So here's our vocab. But before we really jump into some of the words that are for this chapter, I want to just reiterate our 4 steps. Okay. When we get to our 4 steps, because I have highlighted here where we're going to focus on today. But the 4 steps brings all this together, okay? So simplifying slash combining like terms, that is your first step, okay? Now, with that being said, you literally have a checklist because simplifying is just an ambiguous word. So let's talk about what simplifying really means. Well, you need to check off, is there anything to do with PEMDAS? That's the first thing and foremost. Then the second thing, can I distribute anything? The third thing would be to remove fractions. And of course, the last thing is factoring, which we haven't gotten to yet, but we will talk about factoring, okay? And then after I figure out, okay, can I simplify or not simplify, I then make sure that I have combined all the like terms together, and that will complete your first step. You will spend most of your time doing this first step, because once you get to step 2, 3, and especially 4, it's pretty much already done. Okay? So when we simplify, the first thing that we have to know how to do is PEMDAS. Okay? Now PEMDAS we all know. Please excuse my dear Aunt Sally, but we know that P's for parentheses, exponents, multiplication, division, addition, and subtraction. And remember, all of these are leveled. So they're paired up. This is level 1, level 2, level 3. Why do we have the levels? So we know which ones to do first. This is nothing more than order of operations. So it tells us what to do in what order, okay? So we're going to focus on addition subtraction, which is the last thing that you'll be doing for PEMDAS. But if I'm on the same level, what's the rule? If I have, let's say, 3 plus 4 minus 8, how do I know which one to do first? Because they're on the same level. We invoke the rule that says just go from left to right, okay? Does that make sense? That's how simple it is. But now, we have this property called commutative property. What does this allow us to do? Well, the commutative property says this. I can switch the order. Why? It's a really simple rule, okay? 3 plus 4. What does that equal to? 7. What is 4 plus 3? Again, it's 7. So whenever you are adding, not subtracting, whenever you are adding, you can switch the order and then you'll come out with the same answer. So now, if I had something that's a little bit more, let's say, complicated, which it really isn't, but let's say 3 plus x, 4 plus 4y, plus 8x plus 2y. Well, they're all mixed in, and according to what we just said, we should be going from left to right, but we see that these are different families. Okay, this is a Y family, this is the X family. So what am I allowed to do? This is really combining like terms, but the commutative property allows us to do what? Switch the order. So now I can say 3x plus 8x plus 4y plus 2y. Now, when I combine like terms, what do I get? I can easily see that it's 11x plus 6y. Okay, so the commutative property allows us to make what? The problem easier for who? For us. That's why it's part of the simplifying step. Okay, now what does the associative property of addition mean? Well, this one says I can sit there and group. All right, so this is how I group the terms. Okay, all right, so let's say that I have 3 plus, and let's use these parentheses. So immediately, you know, associative property comes when you have these parentheses, okay? So 3 plus, and let's say 8 plus 2, okay? This really says that I can do the same thing over here. I can really say 3 plus 8 plus 2. All I did was switch the grouping, correct? Remember, addition. Keep it with addition. Don't get willy-nilly with it. So let's see what this does. 3 plus, what's 8 plus 2? Because we do parentheses first. That's nothing more than 10. And 3 plus 10 is what? 13. Okay, let's come over here. 3 plus 8. 11. 11 plus 2. What's 11 plus 2? 13. Notice that they are exactly the same. Okay, now as we go through with polynomials, this is going to be very, very effective for us to be able to do both of these, the commutative property and the associative property. Okay, so commutative, think about it. We want to just sit there and be able to switch the order. Okay, associative property, we're able to switch the grouping. Okay. And then, of course, we've already gone over this term, the distributive property, but the distributive property is nothing more than what? Multiplication. Okay, and what are you multiplying? You are multiplying one term, I'm going to just say one term on the outside of the parentheses. I'll just use the symbols of the parentheses to all of the terms. Where? On the inside. Does that make sense? Trying to break it down so you can understand it no matter what. Okay, so here we go. Let's say 3. 3 is a term. It's just a constant, but it's a term. Now we put parentheses. As soon as I put parentheses, I know that that says 3 times whatever is on the inside. Now let's add a couple of terms. Let's say x plus y. Okay, now here's what's really important. We do something called these arrows. And anytime you see an arrow, what math property are we really talking about? Yes, multiply. Okay, we are going to multiply whatever's on both ends of this arrow. So when I do distributing, I distribute the 3 into the parentheses by drawing these arrows. So how many arrows do you see? 2, because there's 2 different terms. How do I know there's 2 terms? They're separated by the what? Plus sign. Okay, so now this says 3 times x plus what? 3 times y. How do I know that? Because of this arrow. 3 times x, that's what the arrow means. 3 times y. Does that make sense? So that's how simple it is. And now that we have this, we're able to just do it. 3 times x is what? 3x. What's 3 times y? 3y. Okay? So here's what I really want to drive home. What happens when there's just a plus sign? Let's say there was 3 plus, and then this set of parentheses, let's say 4 plus z. Okay? Is there anything to distribute? All right. Most of the people would say, no, you can just drop the parentheses because it says plus, but this is what you're really doing. Remember the understood 1? There's an understood 1 right there. So we can distribute this positive 1 into the parentheses. Now, you're probably looking like, okay, you're overkilling it, but I'm really not, because it's going to come important when that sign changes. So this really means 3 plus 1 times 4, which is 4, and 1 times z, which is just z. So you get the expression 7 plus z. And that's real simple. But what if I give you the same exact problem, but I put a negative sign there and say 4 plus z? Again, what number is out in front of this parentheses? It's a negative 1. Now things change. So when I distribute this in, I get 3. That didn't change. Well, now this says negative 1 times 4. A negative times a positive is a what? Negative. So now the 4 turns negative. A negative 1 times the z, I get negative z. So now my answer is what? 3 minus 4? That's just 4 minus 3. I get 1. Keep the sign of the bigger number. So it's negative 1 minus z. So do you see how important knowing what this sign is changes our answers? Okay? It's a big influence. So you need to make sure that am I distributing this positive 1 or am I distributing a negative 1? Because it will change the way the answers look and what their values are. Okay, so that is our distributed property. In a nutcase, I can make it bigger. I can not just do constants. I can have anything. I can have a 3x multiplied by, let's say, 4x plus z. And if I have that, I distribute the whole thing in the 3x and the 3x. So that rewritten would be 3x times what? 4x. Don't forget the sign. Plus 3x times what? Z. And if I want to simplify this, this simply is multiplication. So 3 times 4. Always do the constants first when you multiply. So 3 times 4 is what? 12. Good. Now I have x times what? X. Well, let's make sure we understand this. This says x times x. What's the power of that 1x? 1. What's the power of the other x? 1. If you do not see a power, it's understood to be 1. Whenever I multiply variables together and they're the same variable, what do I do with those exponents? I add them. So when I add them, I get x squared. Okay, just a quick review. So I have 12x squared. Don't forget the sign. Plus, what's 3 times, what's the coefficient of z? 1. So it's 3 times 1. And then x times z is just what? Xz. Now, the reason why I'm taking some time on this is to make sure these understood ones is where I think a lot of you start getting a little bit confused. You don't know where to multiply. Can I multiply this together? Can I add it together? Can I subtract it? All those different things. There's more restrictions on addition and subtraction than there is when it comes to multiplication and division. Okay, so here we go. The last one, let's say that it's 4xy times b plus m. Okay, notice it doesn't really matter what I put in there. I have 2 terms. Matter of fact, let's add one more term just so you understand that it's not just always going to be 2 terms. Let's say minus 6. Okay, so I have 4xy times b times m times negative 6. How many arrows do you see? 3. How many problems are you going to have? 3. So that says 4xy times b. Don't forget the sign. Plus. So I get 4xy again times what? M. Then I, don't forget the sign, 4xy times 6. Does that make sense? And now I can just simplify it. So 4xy times b. That's nothing more than, and now, here's one thing about variables. When you're putting it in, you always go with the highest power first. Then you sit there and make sure that it's in alphabetical order. So which one goes first? Well, of course, b, and then xy. Now I got 4xy times m. So 4m x times y. Okay, all I'm doing is saying 4 times m times x times y. Okay, and I put them in order, alphabetical order. Now, a negative times a positive is a negative. So 4 times 6, because these are both constants. 4 times 6 is what? 24 xy. And that's it. It's already in order. Does that make sense? All right, now let's make sure that we have all our terms. I really beat up distributive property just to make sure that you understand exactly what you're doing. We've gone over combining like terms. I just want to reiterate, remember, the variable and the what? The power of the variable all have to be the what? Same. Now, I can put in parentheses right here an s because I know that x plus x. Now, combining like terms, remember, that is when we're talking about addition and subtraction. Multiplication and division, I can multiply anything together and I can divide pretty much everything, okay? But when it comes to addition and subtraction, they must be like terms. So this is an x to what power? 1. This is an x to what power? 1. So I'm able to add them together. What are the coefficients? 1 and 1. That's what we're adding. So 1 plus 1 is 2. Guess what? You can easily count these. I have 1, 2 x's. Now, let's make it a little bit harder. Let's not keep it there. So xy, let's put a 3 plus x, let's put 2x squared y squared minus x squared y cubed minus 10x squared y squared. Well, here we go. I need to make sure that all of these are the same. So first one I come to, I'm going to just start. I go left to right. Makes your life easy. I don't skip around. So I look, I see x squared. Now I look in the other terms for the same x squared. Oh, well, here's an x squared. Well, now I got to check its partner because it's x times that y. So y is to the third. Well, y over here is not to the third. So they're not in the same family. So I go to the next term. Well, I see x squared again. There we go. Beautiful. But I got to check the y. Y cubed. Here's y cubed. So these two are immediate family. Okay? And I check the next term. Here's x squared. Yay. But the y is squared. So they're not the same family. So now I come over and I see x squared. See if I can match it up. We already know that's not the same family. We look over here. Here's x squared. Okay. Well, y is what? Y squared. Over here, y is squared also. So these two are exactly the same family. Now, because of the what property? Commutative property, I can switch the orders. So let's pair up the families. I have x squared, y cubed. Don't forget the sign. I have negative x squared, y cubed. Now, with the other family, these two, here we go. I get a positive 2x squared, y squared. I have a negative 10x squared, y squared. And now, because I've grouped them together, I can easily do it. Okay? Here we go. I have x. What's the coefficient of this? 1. What's the coefficient of the other one? Negative 1. So since they're exactly the same, this says 1 minus 1. What is that? It's really 0. And we know that anything times 0 is what? 0. So that cancels itself out. So here we go. Let's do the next one. This says 2x squared y squared minus 10x squared y squared. So what am I really doing? I am taking 10. I'm going to subtract 2. Because the signs are different, I'm going to put the bigger on top, smaller on the bottom, and subtract them. And I get 8. But I keep the sign of the bigger number. So I get negative 8. So negative 8, and then I just write x squared, y squared. Notice that when it comes to addition and subtraction, the variables don't change, neither do the powers. Keep the powers exactly the way they are. Is that true for multiplication and division? No. Okay. So addition, subtraction, let's stay focused. My answer then would be just negative 8 squared, negative 8x squared, y squared. Does that make sense? Okay, so now that we've gone through all of that, then now life is easy. We want to know how to add polynomials. Well, look at what we have here for the first problem. Pretty simple, right? It says 6x squared plus 5x plus 2. Is there anything to do in the parentheses? Because remember, that's PEMDAS. Always do PEMDAS first. Well, is x squared and x to the first power, are they in the same family? No, and 2 is a constant. So nothing to do. Let's look at another one. Negative 4x squared. Here's an x to the first power. Nope, they're not in the same family, and negative 7 is a constant. So they're good. So we have a polynomial. This one is a trinomial. Just want to reiterate some of the terms we know. This one over here is also a trinomial. Okay, why? Because it has 3 terms. 1, 2, 3. Terms are separated by what? Addition, subtraction. 1, 2, 3. So those are our terms. Cool. All right, so how do we add these things together? Well, it says take this polynomial, add it to this polynomial. Remember, we went over this. What is this number out in front of this parentheses? Yes, it's a 1. It's understood to be 1. So anything happened to the first one? No, so we're just going to rewrite it. 6x squared plus 5x plus 2. Now we distribute a what? Positive 1. So here we go. 1 times a negative 4. A positive times a negative is a negative 4x squared. Positive times a positive is a positive, so 1 times 3x is just 3x. 1 times negative 7, a positive and a negative is a negative, so I get that. So all I did when I distribute the 1 is rewrite it and drop the parentheses, essentially, okay? But now, let's go through. I have an x squared. Is there an immediate family member with it? Well, here's an x. Nope, that's not immediate. 2's constant. Nope. Oh, here's an x squared. I can write these together. So I have 6x squared. Keep the sign, negative 4x squared. All right, so those are my first family members that went together. Now, here's an x to the what? First power. 2's not part of that family. 3 is. 3x is, because that's to the first power. And 7 isn't. So I combine those two. So here we go. Don't forget the sign. Plus 5x plus 3x. There we go. And then I have a 2, which is a constant. Are there any more constants? Yes, this negative 7. So I put those together. Plus 2 minus 7. Now, people get fancy and put parentheses and everything else, but essentially all you're doing, that was the first step. I did combine like terms. Now, these are expressions, so they're not equations. It's not on the left side or the right side of the equal sign. So I'm just going to combine these like terms, and now I'm going to do what? PEMDAS. Okay. So here we go. What was the first step? That was what? We distributed. We distributed a positive 1. Then we combine like terms. Then we are going to do PEMDAS, which is what? We're going to do this part right here, addition and subtraction. So if you notice, all we're doing is the first step. I told you it's the most important step for you to understand and know. So 6 minus 4, because whenever I combine like terms and this one is subtraction, I'm only dealing with the coefficients. So 6 minus 4 is 2. Keep the variable, keep the power. Don't mess with them, okay? Now, plus 5x plus 3x. I'm adding 5 plus 3. So I get 8x. Keep the same variable and same power. Now I have what? 2 minus 7. Well, they have opposite signs. So I'm really going to do 7 minus 2. Take the bigger number, put it on top. Smaller number on the bottom. Subtract them. I get 5. But I'm going to keep the sign of the bigger number. So I have negative 5. Now, remember what we learned before. What is this? How many terms do we have? 1, 2, 3. So I know it's a trinomial. Okay. What is the highest power of one of the terms? Well, this is a power of 1. That doesn't have a power. This is a power of what? 2. So I have a second degree trinomial. Okay, so example number 2. Again, we're adding what? 2 trinomials together. The number here is a positive 1. We're going to distribute this in. All right, so 4 steps. You'll never get away from it. Okay, we check PEMDAS. There's nothing to do in the parentheses, and so everything's good. So we can distribute. We're distributing a positive 1. So I can rewrite this. 5x squared minus 2x plus 3. 1 times x squared. 1 times x. 1 times 2. Does that make sense? All right, so what are we going to do next? You got it. We're going to combine like terms. So I'm finding all the like terms. Here is x squared. Here is x squared. So let's combine those. I got 5x squared plus x squared. Next, I have a negative 2x. I have a positive x. Those are negative 2x, positive x. Then I have a constant, which is 3, a constant, which is 2. So I have plus 3 plus 2. And now what am I going to do again? You got it. I am going to use PEMDAS. Okay, why? Because I'm adding these like terms together. Okay, so 5, what's this coefficient? There's a 1. So there 5 plus 1 is 6. Keep your variable, keep the sign. This is 2, what's this? 1. Opposite signs, so that says 2 minus 1. I get 1. Keep the sign of the bigger number, so negative. Do I have to write the 1? No, so I can just keep it negative x squared. Then I have plus 3 plus 2, so that is nothing more than 5. What is your answer? Simplified format, it is a second degree, what? Trinomial. Cool. All right, so let's move to subtracting polynomials. What is the difference between subtracting polynomials and adding polynomials? That sign right there in the middle. That's it. PEMDAS still works out, so 6x squared plus 5x plus 2. Notice this is the same exact problem, but we're going to subtract. There's a understood what here? Negative 1. So what do we have to do with that negative 1? You got it. We're going to distribute. So I have 1 arrow, 2 arrows, 3 arrows. Why? Because I have 3 different terms inside the parentheses. So let's rewrite it. I have 6x squared plus 5x plus 2. Now let's distribute. Negative 1 times negative 4x squared. A negative and a negative is a positive, so I get 4x squared. Negative 1 times 3x. A negative and a positive gets you a negative. And then I have negative 1 times negative 7. A negative and a negative is a what? Positive. So now all I have to do is what? Combine like terms. I am going to literally combine like terms. Now, I know I've been separating the combine like terms into 2 different steps, but that's just right now so we can sit there and make sure that you understand exactly what to do. So here is an x squared. Here's an x squared. Notice I'm circling the sign that goes along with it, okay? Here is a 5x. Here's a negative 3x. And then here is a positive 2 and a positive 7. So I color coded it so you can make your life easy and see which ones need to be combined. So it's 6x squared plus 4x squared. It is plus 5x minus 3x. And then there is a plus 2 and a plus 7. So now, when you combine like terms, all you're really doing is the PEMDAS portion of it, okay? I'm just really breaking this down for you, okay? you can definitely do these things in your head. So here we go. 6 plus 4 is what? 10. Keep the variable, keep the sign. 5 minus 3 is 2. Keep the variable, keep the power, okay? And then we have 2 plus 7 is 9. What did I just get? A second degree what? Trinomial. Good job. What's tri mean? Trinomial. Got to make sure you know how to spell sometimes, right? Mathematicians? All right. So tri means what? 3. I have 3 terms. How do I know I have 3 terms? Because they're separated by the positive or negative signs. Okay. Example number 2 for subtraction of polynomials. I now see everything's in parentheses. I have a negative 1 right here, so I'm going to distribute this into this second set of parentheses. That is distributing. So let's rewrite it. 5x squared minus 2x plus 3. Negative 1 distributed in. So that says negative 1 times x squared. So I get negative x squared. Negative 1 times a positive x. A negative times a positive is still a negative. So I get negative x. Negative times a positive 2. So I get negative 2 right there. So now I'm just going to do what? Combine the like terms. Notice I just go through and I circle all the ones that are in the same immediate family. So 5x squared is the same as x squared. This is a negative 1 right there. All right, so negative 2x, negative 1x. They go together. And then I have constants, a positive 3 and a negative 2. Now let's write it out. I have 5x squared minus 1x squared. Done there. Okay, so then I get a negative 2x and a negative 1x. And then I get a positive 3 and a minus 2. Okay, so now you're able to do what? What you do best. Add them up or subtract them. All right, so here we go. 5 minus 1 is what? 4. So I get 4x squared. Negative 2 minus 1 is negative 3. They have the same sign, so you add them and keep the sign, okay? So negative 3x. Positive 3 minus 2, different signs, so subtract them. 3 minus 2, I get positive 1 because I keep the sign of the bigger number. So now what do I get? Second degree trinomial. All right? Tri meaning 3. Okay, so our practice problems, we got to make sure we're able to put all this together. Remember commutative property, associative property, and being able to do it all. So here we go. Here's our problem right here. I'm looking at it. I have one term outside of parentheses, then I have a trinomial, then another trinomial. I'm adding one side, I'm subtracting the other side. Well, first things we got to do is always PEMDAS. Go through your checklist. It goes PEMDAS, then what? Distribute, then what? Remove fractions, then what? Factoring. Remember? So let's go through PEMDAS first. Anything to add or subtract or multiply, divide, or parentheses and everything. There are parentheses, but there's nothing inside the parentheses that we can do. And there are powers, but there's nothing that we can do with those. PEMDAS is done. Distribute. Can we distribute anything? Yes. There is a positive 1 here, so I can distribute this. And we know now that just having a positive 1 there is really just it's dropping the parentheses, okay? But here I have a negative 1. And when I distribute that, what's going to happen? It's going to change all of those signs. So here we go. I have 2b cubed. Nothing happened to it. It's already on the outside. A positive 1 times that 6b squared is just 6b squared. A positive 1 times that negative 3b is still just a negative 3b. A positive 1 times a positive 4 is just 4. Now here's where it switches. Negative 1 times a positive 8b cubed is a negative 8b cubed. Does that make sense? All right. A negative 1 times a negative 2b. A negative and a negative is a positive. So I get 2b. And then a negative 1 times a negative 8. Negative and negative is a positive 8. So what are we able to do now? Nothing to do with fractions, nothing to do with factoring. So we are going to do combine like terms. So here we go. Let's just circle them. 2b cubed goes with what? Negative 8b cubed. Positive 6b squared goes with what? Nothing. There's nothing there. Correct. Negative 3b goes with a positive 2b. And then there is a positive 4, which is a constant, and a positive 8. Now let's group them. Here we go. 2b cubed goes with negative 8b cubed. The positive 6b squared was all alone. Negative 3b plus 2b goes together. And then a positive 4 and a positive 8. Okay? So, now what do we do? That's right. Just work that PEMDAS out. We're going to add and subtract these things. So 2 minus 8. Opposite signs, right? Positive 2, negative 8. So that really says 8 minus 2. 8 minus 2 is 6. Keep the sign of the bigger number. So I get negative 6 and just keep the variable, keep the power. What about this 6b? Anything with it? Nope. So just leave it 6b squared. This is negative 3 plus 2. Opposite signs. So what do? Subtract the smaller from the bigger. So I get 3 minus 2. Keep the sign of the bigger number. So negative, that's really 3 minus 2 is 1. So I get 1b. I don't really have to write the 1, okay?